Who says oxygen? Who says hydrogen? Who's not really sure? Well, you gotta be one of those three. Y'all can vote. Lithium's attracted to oxygen. Why is it attracted to oxygen? Because positive and negative, right? The oxygen in water is partially negative, lithium's positive. So that means that the chloride ions are going to be attracted to hydrogen, because chloride is negative, hydrogen is partially positive. Opposites attract. Remember, we're not PCing here. All right, think about these. I want you to think about each four of these, and then we're going to talk about them. Okay? Think about, is it polar or non-polar, right? Polar dissolved in water, and by polar, it could be ionic. Ionic is like really polar, dissolves, okay? So think about these for just a minute. You might need to use your book, you might need electronegativity values, I don't know. Are we ready? All right, the first one. Think it'll dissolve?
Yes.
Who says yes? Raise your hand. Why am I trying to get you to raise your hand? What do we know about sodium sulfate? It's ionic, isn't it? That's a polyatomic ion. This is an ionic compound. What do we know about ionic compounds? They tend to dissolve in water, don't they? Right? Sodium chloride dissolves. Why wouldn't sodium sulfate dissolve? Okay. Gasoline, non-polar. Does it dissolve in water?
No.
You get gasoline in your car in the tank, your gas tank in your car, mess up your car, right? What about C, iodine? Think it'll dissolve?
No.
Why not?
It's non-polar.
How do you know it's non-polar? Because you got two atoms with exactly the same electronegativity. It is non-polar. So it does not dissolve. Or not very well. A little bit. Huh? I2. Do both of these atoms have the same electronegativity? Yes. That means it is non-polar. This one? How to do this one? I recognize that as being a polyatomic ion. This compound is ionic. Ionic things dissolve, right? They have charge, they dissolve.
Now what if you didn't know it was ionic?
Well, you need to know that it's ionic. You need to recognize that that's sulfate. That's polyatomic ion. You got to do that. You got to recognize this is an ionic compound. We learned that in chapter 4. Or whatever chapter it was. Way back when. Seems like months ago now. 6, 4, 6, whatever. When we name stuff. That was chapter 5.
We're supposed to remember all of it.
You can't even remember it.
I don't remember what chapter it's in, but I know that we've covered it.
We skipped chapter 5.
We skipped 5, so it was 4. Naming ionic and covalent compounds in chapter 4. Okay. What about this one? That's a tough one. This one, if you look it up in the in your book, the electronegativity value for chlorine is what? 3.0. For hydrogen, it is 2.1. The difference is 0.9. Right? Is it polar or non-polar? It is polar. That value is greater than 0.4, isn't it? So, does it dissolve in water?
Yes.
Yes, it does.
How do you know?
Because I've done this problem dozens of times. If you don't know, then you got to look at the electronegativity values on page, what page is that page? Page 189. Right? Was I right? 3.0 and 2.1? Oh boy. I've been teaching this too long to know the values, huh? Okay. So, what happens when we put these ionic things in solution? So when you put sodium chloride in solution, it dissolves, right? Most of you have probably heard this term electrolytes before. Where do you hear the term electrolytes at?
Things like
Gatorade, Pedialyte, Pediasure, Powerade. They're used
in your blood.
in your blood, in a IV bag that they hang in the hospital. See, I did my PhD at Florida State. They don't drink Gatorade at Florida State because Gatorade was developed at the University of Florida. They're in Powerade. They used to drink 10K. That was nasty stuff.
What was it called?
10K. It was made by Pepsi.
Huh.
But you know what most athletes drink now? They don't drink Gatorade or Powerade. They drink Pedialyte. That's a lot of Pedialyte. It's the same stuff. Okay. What does it mean it's an electrolyte? That's a good question, huh? What are we drinking if we're trying to replace electrolytes? It's a fancy word for replacing ions. Okay? You're trying to replace the ions. When you sweat, you lose not only water, but you're losing some solution, right? That solution contains ions in it, doesn't it? So just like when you come out of the water at the beach and you let the water dry off on you, if you sweat and then you let it dry, anybody ever done this? And then you taste your skin? You've never done that? You taste salty? That's why when you sweat, your dog comes up and licks you. You never done that? Dog doesn't come up and lick you when you sweat.
That's, yeah.
Your dog licks you when you sweat?
That's weird.
It is weird, isn't it?
What you just said.
Why do they lick you? Because there's salt on your skin. Then the salt tastes good, right? So, electrolytes are the ions that are dissolved in a solution, like sodium, potassium, chloride, bicarbonate, all those kinds of things. So, there are two kinds of electrolytes. Well, two kinds, and then there's one that's not an electrolyte. So there's three things you gotta know here. Strong electrolyte. A strong electrolyte is something when I put it in solution, in water, it breaks apart 100%. Look down here at my equation. Here we have sodium chloride. When I put it in water, 100% of it goes to form sodium ions and chloride ions. Okay? Note there's a one-headed arrow. This is a one-way street, can't come back. All of it forms sodium ions and chloride ions. Now, if I put two electrodes into water, there's no ions in water. They don't conduct electricity. They need these ions to conduct electricity. It's called a strong electrolyte because it makes lots of ions that are capable of conducting electricity, and the light bulb lights up bright. Okay? So strong electrolyte. You put it in solution, it dissolves 100%, and it will light up the light bulb. A weak electrolyte, when you put it in solution in water, only part of it comes over here. So only part goes that way. Okay? Normally much less than 50%. So only some of it comes over here. Note that we have a different arrow here. It's a two-headed arrow. Like that. Okay? Only some of it forms products. So we don't get the same number of ions that we would have gotten if we were a strong electrolyte. This is called a weak electrolyte. Note that it carries some current, but not as much current as a strong electrolyte. So the light bulb lights, but it's kind of dim, right? It's not so bright. Now, the third thing is not an electrolyte. It's a non-electrolyte. It still dissolves in water, but it doesn't form any ions. Good example is sugar, right? Sucrose. You put it in water, it dissolves, but look at the difference down here in my equation. It goes solid to aqueous, but there's no change in the formula here, okay? Does everybody see that? It's a one-headed arrow. It dissolves, goes from solid to aqueous. Now it doesn't carry any charge. It is a non-electrolyte. Light bulb doesn't light up at all. It doesn't say that it doesn't dissolve. It just says it does not form ions. Sugar is a non-electrolyte. Okay? Does not form ions. It just dissolves. Does that make sense? Okay. So, oops. Let's get way ahead. Look at these two right here. Both of these are strong electrolytes. I'm going to do the first one, and I want you guys to do the second one. It says, write the products here. Okay? This right here, what about this? This is calcium chloride. Do we know anything about calcium chloride? What type of compound is it? It's an ionic compound. So I'm going to predict, it says it's a strong electrolyte. Calcium, when it forms ions, what kind of ions does it form? 2+, because it's an alkali metal. And that's aqueous. And what about chloride? What does chloride look like when it is Cl minus, 1-, right? And it's aqueous. And to make it balance, I gotta put a 2 there. Okay? So I want you guys to do the bottom one real quick, and then we'll talk about it.